Let's go ahead and get started. Make use of the time we have together. I just wanted to let you all know that we are recording this session and we'll make the recording available afterwards in case you want to watch it again, share it with colleagues or something like that. And just to make sure you're in the right place, the title of this session is Make AI Come to Life with ChatGPT, or Make Your AI Come to Life. I assume you've all heard about ChatGPT. It's everywhere. In fact, it's a topic of dinner table conversations everywhere. Whether you're technical or not, you've probably gone to the ChatGPT website, seen some of the amazing things that it can do. But what I want to do is go a level deeper with you on it today. I want to explain to you what it is, how it works, which is very useful in terms of knowing, for example, how do you deal with it when it's hallucinating, when it's giving you answers that are incorrect. What can you do about that? And we're going to look at ways to use the ChatGPT API to make your business better and more efficient, to make your apps smarter and more efficient as well. So I'll be showing a lot of code. I'm going to start with a few slides, but this session will be mostly code. And I'll also give you a URL where you can download all of the code samples that I'll be showing. I've parked them in a public GitHub repo so that you can pull those down, play with them yourself, share them with other folks, or do whatever you want to do. So just real quickly, by means of introduction, my name is Jeff Prose. You can see here on the slide how that name is spelled. And you know what, while I do these introductions, why don't I turn my webcam on? This way you can see that it's not an AI bot talking to you, it is a live person. So name is Jeff Prose. I work for Atmosera. My title there is Chief Learning Officer, but where I spend most of my time is helping our customers understand AI, figure out ways to use AI to make their business better and more efficient. I'm incredibly passionate about that, having probably more fun right now in my career than I've had in the last 25 years, because we're on the cusp of a revolution. We have technology available to us now that makes things that would have been difficult or impossible just a few years ago, not only possible, but in some cases very easy to do. The book cover you see there, so back in the 90s and the early 2000s, I wrote a computer book or two. 20 years ago, I said I would never do it again, but I was so excited about what was happening in the world of AI last year that I got a little bit crazy and decided to write one more book. If you want to check it out, you can buy it from Amazon or Walmart or other places there. Unfortunately, the book doesn't cover ChatGPT because the book went to the printer in November of last year, the same week that ChatGPT shipped. It does walk all the way up to ChatGPT, explaining how all this kind of stuff works. And I'm hoping later this year to add a new chapter to the book, specifically on ChatGPT and other OpenAI models. And in fact, even before we do that with the print version, I plan to write that chapter and make it available online for free, because there's so much exciting going on with ChatGPT. Once you learn about it and learn the things you can do with it and how you do it, you'll have probably all sorts of ideas for the way that you can leverage it in your business. So let's go to the first slide. And I am going to stop the screen share at this point, or stop the video feed at this point, now that you know there's a real person. And we're going to spend 15, maybe 20 minutes in slides. It's really important, in my opinion, if you're going to be using ChatGPT, to understand what it is and how it works. And part of building that understanding is knowing where it came from, how we got from where we were just a few years ago to where we are today. So I want to turn the clock back a little bit to the year 2016, 7 years ago, when Google Translate was architected according to the diagram on this slide. By the way, this diagram came from a paper published by Google engineers back in 2016. Up until this time, almost all neural networks or deep learning models built to do natural language processing, like translating text from one language to another, to do speech to text or text to speech, or to do keyword extraction from documents or something. Almost all models built to perform natural language processing tasks were instances of what we refer to as recurrent neural networks. A recurrent neural network typically uses a stack of layers that we call LSTMs. That stands for long short-term memory cells. And the magic of LSTM layers is that it allows us to treat a sentence or a paragraph or an entire document not just as a bunch of words that aren't connected together, but as an ordered sequence of words. So back in 2016, if you went to Google Translate and you typed in an English phrase and asked it to translate it to, say, French or German or Spanish or something like that, it would pass your input through what you see on the left side of this diagram, a bunch of LSTM layers that would turn that input into a vector representation, or what we refer to sometimes as an embedding. And then it would pass that embedding over to the decoder half of the network, which used its own stack of LSTM layers to turn that vector embedding, that array of floating point numbers, into words in the language that you would ask the model to translate it into. This is how virtually all natural language processing was done up through early 2017, late 2016. In 2017, the way we do NLP changed in a big way. And it changed because of a famous paper titled "Attention is All You Need," published by some engineers at Google. And what that paper did is it proposed a new way of doing natural language processing with deep neural networks. That is, doing away with those LSTM layers, getting away from recurrent neural networks altogether, and instead using networks that we refer to as transformers. And the illustration that you see on this slide came from that paper published by Google. Now, what you're seeing in that slide is a transformer encoder decoder. This is the basic architecture of Google Translate today, at least for the most part. There are some nuances that I won't go into. It also represents the core architecture of ChatGPT. And the idea here is that, let's say you want to translate English to French. You first take the English phrase that you want to translate and you feed it into that left bottom input in the diagram. That's the encoder half of the transformer encoder decoder. That data flows through several network layers, and in particular, it flows through one or more layers called multi-head attention layers. Multi-head attention layers are where a lot of the magic lives in transformers. Just one example is when we use LSTM layers, the longer the sequence of text we pass into the network, the less able it is to handle it. You know, if we're going to translate a short sentence with 7 or 8 words or something, recurrent neural networks can handle that easily. They can essentially connect words early in the sentence to words later in the sentence. But if you pass an entire document with hundreds or thousands of words into a recurrent neural network, its ability to do translation or whatever it was designed to do on that input diminishes as the length of the input grows. But thanks to the multi-head attention layers in a transformer-based network, we can model relationships between words in that input independent of the input length. It doesn't matter whether it's a sentence that's 7 or 8 words long or 700 or 800 words long. Thanks to those multi-head attention layers, we can make connections between words. We can better model the context of what is said in and meant in that text that we passed in. The output from the encoder goes over to the decoder half of the transformer encoder. And the decoder half has 2 inputs. One is the output from the encoder. The other is the input that in a neural machine translation problem where you're going from English to French, for example, is the text that has been translated so far. Now, I'll show you exactly what that means here in just a moment. But basically, this architecture, the transformer encoder decoder, completely changed the way we do NLP back in 2017. And models like this one are very adept at taking 2 inputs, like an English sentence and part of a French sentence that has been translated from it, and predicting what the next word in that French sequence is. We then go back through the model again, passing in the English phrase that we want translated and the French that we've translated so far, including the last word that it predicted. And we do that over and over until word by word, we predict, hopefully very accurately, what the French translation for that English input should be. Now, just as an example, and I'm not going to go show the code in this, although you can go look at the code if you want. All the code for the book I showed you a moment ago is in a public GitHub repo called Applied Machine Learning. And one of the many examples in the book shows how to build in Python using Keras and TensorFlow a network that does neural machine translation pretty much just like Google Translate. In the book's example, I trained the model with 50,000 phrase pairs. Each pair consists of an English sentence, a very short English sentence in most cases, and the equivalent French sentence. And you'll notice that I've put start and end tokens at the beginning and end of each French sentence. That's important because you'll see in a moment when we start using this model to translate a new phrase and we iterate to predict word after word after word, it's when the next predicted word is the end token that we know we have finished the translation. Among other things, that means that we don't have to assume that the number of words in the French translation will equal the number of words in the original English, because in most cases, the number of words do not equal each other. Now, this is just a few examples of the 50,000 phrase pairs that I trained with. Realize Google Translate was trained with 25 billion phrase pairs, similar to these right here. So my network can translate English to French, and it's pretty good at it. It's not perfect. It's pretty good when the phrases that you input are short. But if we were to train it with 25 billion phrase pairs like Google Translate did, then we would have a model that's probably very, very adept at translating English to French. So once the model is trained, if we want to use it to translate English to French, here's how we do it. This is what happens under the hood, and as you're going to see in a moment, this is very relevant to how ChatGPT works as well. So remember that our transformer encoder decoder takes two inputs. One is the English phrase that we want to translate. The second is the French phrase that has been translated so far. So for my first call into the model, if I wanted to translate hello world into French, I pass hello world to the English input, and I pass a start token to the French input. What the model then does is compute a probability for all 12,000 or so words in the French vocabulary that I trained the model with, and it picks the word assigned the highest probability as the next word that it predicts. That means that it predicts the first word in the translated French phrase is salute. So that's the first pass through the model. Now I iterate back and make another pass. This time I pass hello world to the English input, and a start token followed by salute, the word that was predicted in the previous pass through the model, into the French input. This time the model predicts with about an 83% probability that the next word should be la. And then we do that again. It believes that the next word will be monde, which is French for world. And then finally, when the next token that the model predicts is the end token, we have completed the translation. So according to this model, hello world in English translates into salute le monde in French. Now, there are actually a lot of different ways to translate hello world from English to French, but salute le monde is a pretty reasonable translation of it. So one thing I want you to take away from that is that when we do neural machine translation a la Google Translate, what we're doing is using a deep learning model that's based on a transformer encoder decoder architecture, one that has two inputs, and we are iteratively calling the model, predicting what the next word in the output should be. We do that over and over until the end token is the next predicted word. And if the model was trained properly, we now have the ability to translate from one language into another. So after that paper, Attention is All You Need, was published in 2017, Google did rewrite Google Translate. It now uses transformers. It still uses some LSTM layers as well, but it's mostly a transformer-based network. In fact, virtually all the advances that have been made in natural language processing since 2017 have been made because of these transformers. But there is a downside to the transformer architecture, and that is that to train a model on billions of phrase pairs or billions of words or something, It takes a lot of time to do it. It's computationally very, very expensive. Typically, models like this are trained on hundreds, even thousands of high-end GPUs that can cost $10,000 to $20,000 each. There are even cases where researchers have borrowed time on a supercomputer to do the training. So the transformer architecture was a real revelation for us, but unless we had access to vast amounts of compute power, it was really hard to build super sophisticated transformer-based deep learning models. So then in 2018, Google helped us there again. They introduced a model that they call BERT. It stands for Bidirectional Encoder Representation for Transformers. And what they essentially did was take a transformer-based deep learning model, and they trained it up on about 3.5 billion words from Wikipedia and from Google Books. What that allowed the model to do was to understand the structure of the English language very well. And by the way, they later trained it on other languages as well. But this one, the first one, was trained on the English language. Now, BERT in and of itself wasn't all that useful. It understood the structure of the English language well, but it wasn't inherently capable of translating phrases from English to French or taking a natural language question and searching a set of documents for an answer for it. But what Google did was they described to us how we can fine-tune the model in order to perform specific NLP tasks. Now, if you're not familiar with the term fine-tuning, it has a very special connotation in the world of deep learning. Fine-tuning typically means we take a model that has already been trained, probably at great time and great expense, and we do some further training on it. Typically, we train it on much fewer samples than the original training regimen comprised, and we do it at a reduced learning rate so that we don't destroy the knowledge that the model gained when it was originally trained or pre-trained, but we're just adding some knowledge into it. So companies started taking the BERT model that was published by Google and fine-tuning it to perform specific tasks like question answering, named entity recognition, keyword extraction, and things like that. And then many of those companies publish those models. So today, you can go to websites like Hugging Face, and you can not only download BERT models already trained up, you can download BERT models that have been fine-tuned to perform specific tasks. And in fact, in one of my demos a little bit later, I'm going to show you one way to do that and what comes out of it at the end. One of the other things that I want to mention about BERT, and one reason that it was so revolutionary, besides the fact that it gave us a head start on building these models, it's kind of like running a 26-mile marathon, by the way. And the pre-training of BERT spots us the first 25 miles. So we do the fine tuning, we run the last mile, but we don't have to run the entire 26 miles. But the other big innovation that BERT introduced was something called masked language modeling, or MLM for short. If you work in machine learning or deep learning, you know that it's often quite time consuming to build a labeled data set. Sure, if you've got a 1,000 rows in that data set and you want to label them, you might sit down in an afternoon and do that. But when you're talking about billions of rows of data, like the ones BERT was trained on, it's difficult to sit down and affix labels to every row in that data set. Mass language modeling prevents us from having to build a labeled data set to train a model like BERT. Essentially, remember, BERT was trained with about 3.5 billion words from Wikipedia and from Google Books. It was trained in an unsupervised manner. We feed batches of text into it, and using mass language modeling, what BERT does is it randomly masks out or drops about 15% of the words. Then it trains itself to predict what the missing words could be or should be. Then we run the next batch of text through. It does the same thing again, masks out about 15% of the words, and trains itself to predict what the missing words should be. This is why BERT is so incredibly important, because not only did Google publish a pre-trained version of it that we could fine-tune to do specific things, but due to mass language modeling, we can just feed in reams and reams of text without having to sit down and affix labels to all of that text first. So BERT was also a really big deal when it was introduced back in 2013. And again, I'm going to be showing you an example in a few moments in putting BERT to work in an actual application. But Google uses BERT as well. You've probably gone to Google and typed in a question like, when did Lindbergh fly across the Atlantic before? But do you know what actually happens behind the scenes when you type in a question like that? Let me tell you what actually happens. The first thing Google does is it uses a deep learning model to convert the question that you asked into an embedding vector. An embedding vector is just an array of floating point numbers. It's typically 1 to 2,000 numbers in length, but the length varies. The idea behind an embedding vector is that with all those floating point numbers, it captures the context and the meaning of the text that you passed into it. Google then takes that embedding and it queries a vector database for similar embeddings. Now, if you've never heard of a vector database before, a vector database is one that is specifically built to store embedding vectors and the text that is associated with them. If we have billions of embedding vectors that we've generated from billions of web pages, we can drop all of those into a vector database. And if it's good, then we can do a query and say, hey, give me the 10 vectors that are the most similar to this one, or give me the 50 that are the most similar, and it will pull them out very, very quickly. Internally, these databases typically use simple mathematical operations like dot products or cosine similarity to find similar embeddings. But that's really not that relevant. What is relevant is that we first convert your question into embedding vector, then we consult a vector database to find the n most similar embeddings, and we retrieve the text that those embeddings were generated from. What Google then does is it uses a fine-tuned version of BERT, a version that has been fine-tuned on a famous data set from Stanford to look inside a document and find an answer to a question that you pose to see if it can answer the question that you typed. If it doesn't think it has found an answer, or if it's not confident enough in the answer it found, Google will just show you a list of links so that you can click the links and go find the answer yourself. But if their fine-tuned version of BERT finds an answer to the question in those documents retrieved from the database, and the confidence level is high enough, Google will actually then show you the answer to the question. It'll still show you the link so you can click it and go learn more, but it will show you what it believes is the answer to the question. So this is just one of the many ways that BERT is used today. And it's not just Google that's using it. A lot of companies use BERT. BERT was the world's first large language model, or LLM. You've probably heard that term a lot lately, large language model, because guess what? ChatGPT is a large language model. In fact, it was the biggest and most complex one ever built until GPT-4 came out just a few weeks ago. But before we talk about ChatGPT, let's talk a little bit about what led up to it. In 2018, a startup, a new company that was co-founded by Elon Musk called OpenAI published a large language model called GPT-1. It was like BERT in some ways, but it also did a few things that BERT didn't. It was actually a little bit smaller than BERT, but it was really OpenAI's first public foray into large language models. They followed that up in 2019 with a model called GPT-2. And then in 2020, something interesting happened. OpenAI published a model called GPT-3. At the time, it was the largest and most complex neural network ever built. It has 175 billion parameters. Now, if you're not familiar with parameters in a neural network, it's the parameter count that we use to measure the size and complexity of a neural network. 175 billion parameters means this is one big network. Think about an equation that has 175 billion terms and assume that you can adjust the coefficients on those terms in order to get the outcome you want. That's essentially what GPT-3 is. It was trained on a massive data set of roughly 500 billion words from some famous data sets like the Common Crawl data set and the Web Text data set, and a pair of large books data sets as well. Now, as you'll see in a moment, ChatGPT derives from GPT-3, but more recently, OpenAI has published GPT-4. Now, we think that it is now the largest large language model ever built. OpenAI has not told us how many parameters it comprises, but it is reported to be in the neighborhood of 1 trillion parameters, so 5 or 6 times larger than GPT-3. One thing that's interesting about GPT-4 is that it not only accepts text as input, it also accepts images, and I'll say a little bit more about that later. But what does all of this have to do with ChatGPT? In November of last year, OpenAI introduced ChatGPT, and it quickly grew from 0 users into 100 million users. It is believed to be the fastest growing app in terms of users in history. In order to build ChatGPT, OpenAI started with GPT 3.5, which was a fine-tuned version of their earlier GPT-3 model. Then they did some additional fine-tuning. They took 13,000 supervised learning samples. Each sample was basically a prompt, like write a short story that begins with certain words, or translate this phrase from English to French. And they generated responses for those things by hand. They actually hired a team of 40 contractors to generate those responses. Then they took those 13,000 samples of prompts and the responses that they would like to see from ChatGPT, and they fine-tuned GPT 3.5 with it. Now, at that point, ChatGPT was functional. It could take new prompts and it could generate new output from it. But they wanted to go a little bit further. They wanted to train ChatGPT to try to be accurate, if possible, to try not to say things that would be offensive or inappropriate or things like that. So what they did is they asked the model to generate responses, several responses, typically 5 to 10 responses, to each of tens of thousands of sample prompts. Then they used humans to rank each one of the responses, basically grade it. Is it an A, a B, a C, or whatever? And then they went back and executed a reinforcement learning step to train ChatGPT to favor those responses that had been assigned the highest scores. Now, it's not perfect. We can coerce ChatGPT into saying things like it wants to take over the world, or even saying harmful or hurtful things, but it's not as bad as it would have been had they not gone through this reinforcement learning phase. And you can bet that one of the things that OpenAI is doing right now is going back and probably doing additional fine-tuning there, just to make sure, to the extent that's humanly possible, that ChatGPT won't be saying things that will offend people or that could be dangerous or something like that. Now, I want to show you how ChatGPT actually works in just a moment, and then get into some examples. But first, I want to show you a little bit of code. On March 1st of this year, OpenAI introduced the ChatGPT API. Now, remember, ChatGPT was introduced back in November, and you could go to the ChatGPT website and you could type in prompts, and it would generate responses for you. But it wasn't until March 1st, when the API was introduced, that we could really begin incorporating ChatGPT into the software that we write, whether that's public-facing software or software tooling, for example, that we're using to make our business better and more efficient. So you can call the ChatGPT API in any programming language that you want. It's merely a REST API. Most of my examples will be done in Python, but realize that doesn't mean it has to be done in Python. What I've done is installed a Python package named OpenAI, which provides a really nice and easy to use wrapper around the REST ChatGPT API. And once I've installed that package, it's really easy for me to make calls to ChatGPT from Python using code like this. I first inform ChatGPT about, I give it my API key. This is something that essentially identifies me. Once I register on the ChatGPT website, I can then grab an API key. You don't even necessarily have to be a paid member to do it. You can have a free account and you can still retrieve an API key. But that API key needs to be passed in every call to the ChatGPT API so that it can essentially authenticate you. And if you're going to be billed for it, this tells it who to bill or what account to bill. In this example, I'm giving ChatGPT the command or the prompt, complete the sentence, every good. And it's in those final few lines you see at the bottom where the call actually goes out over the wire. And that call to openai.chatcompletion.create, identify the model that I want this call directed to. GPT 3.5 Turbo is ChatGPT. There are dozens of other models that you can invoke, by the way, but this one is ChatGPT. And the messages parameter identifies that messages array that contains the command that I'm passing to ChatGPT. So with the OpenAI package and with an API key, it is almost trivially easy to make calls to the ChatGPT API. One little trick that's not very obvious in the documentation is that you can enable streaming when you do the call. Notice in this example, which is pretty much like the one in the previous slide, I've added a stream equals true parameter to the call. Now, if you've visited the ChatGPT website and you've typed in a command like write a short story that begins with a dark and stormy night, you've seen how the text sort of streams. It appears as it becomes available. You can actually see it being written out. If you call the ChatGPT API, as I did on the previous slide, the call doesn't return until all of the text has been generated. But if you call the API this way, you'll actually see the text come back in chunks and displayed as it comes available. It delivers a very nice user experience. You'll see this in several of my examples, and it's easy to do once you know how. The problem is there's not a ton of documentation around this stuff right now. There's another way to call ChatGPT as well. And this is incredibly important, especially if you work in an enterprise, and if that enterprise is an Azure customer. You probably know that Microsoft and Azure have a very, very close partnership. Microsoft has invested a lot of money in OpenAI, and now you can access OpenAI models through Azure. And there are a lot of reasons that you might want to consider doing that. For example, when I make a call out to the ChatGPT API to ChatGPT itself, that data is traveling out over the public internet. And there have already been some instances documented online where employees of companies have sent data off to ChatGPT that they shouldn't have sent because there was proprietary data there. One of the great things about accessing ChatGPT through Azure is that you can deploy private instances of ChatGPT and other OpenAI models in Azure. And now, when you make calls to them, that data is going through Azure, but it's not going out over the public internet. Also, if you value things like availability, scalability, reliability, you can achieve that through Azure because you can deploy multiple instances of these models and set scaling rules to have them scaled out and things like that to handle whatever load they might incur. The nice thing is, if you choose, rather than call ChatGPT directly through its API, if you choose to instead call a private instance of ChatGPT that you've deployed in Azure, the code is almost exactly the same as the code you saw previously. Now, I go out to the Azure portal after I've created an OpenAI resource and deployed one or more models into it. And from the portal, I get an endpoint, the URL through which I can reach the model, and an API key. I provide those to OpenAI this way, and then I use the same chatcompletion.create API to send off calls to my own private instance of ChatGPT. You'll notice that I've highlighted in yellow the parameter named engine. When you're calling ChatGPT directly, you use the model parameter there. When you're calling it through Azure, you use the engine parameter instead. And that my ChatGPT instance is just the name that you assigned to this instance when you deployed it in Azure. So you can call ChatGPT and its API with or without Azure. There are a lot of benefits to calling it through Azure, but if your shop is an AWS shop or something like that, you're prevented from using Azure for some reason, you don't have to have Azure. It is highly recommended, though. Before we put away the slides and look at some actual code, let me describe to you what actually happens when you make a call to ChatGPT and ask it to generate some text. Now think back to that English to French translation example we looked at a few minutes ago, where the model has two inputs, the English phrase to be translated and the French phrase translated so far. And you'll recall that we call that model iteratively, and all it's really doing is predicting the next word over and over until it's completed. ChatGPT works essentially the same way. It takes the prompt that you feed into it, like complete the sentence every good, and it feeds that into one of the model's inputs. It also feeds a start token into the other input. And what ChatGPT does in its output is it generates a list of probabilities for every possible word that could come next. In this case, it thinks based on the 500 billion or so words that it was trained with, that there's about a 66% chance that the next word in the sentence should be thing. It then calls back into itself, passing in complete the sentence every good to one input and thing to the other. And this time it comes up with must as the most probable word. And it does this over and over and over until it sees an end token saying that the translation or the prediction is complete. Now you'll notice in this example that in computing probabilities for each word, ChatGPT always picked the word with the highest probability. That's actually not the default in ChatGPT. That works, and sometimes it's appropriate because if you're asking to generate code, for example, you may want that code to be consistent from one run to another. But if you're having it generate prose, picking the most likely word in every iteration can sometimes make that prose feel sort of stilted and unnatural. That's why ChatGPT exposes a handful of parameters, one of which is named temperature, that lets us exert control over this. If we set temperature to 0 when we call ChatGPT, then it does always pick the word with the highest probability, as you see here. But if we set temperature to something higher, and it does default to a non-zero value, by the way, then ChatGPT will occasionally and somewhat randomly pick words with lower probabilities. This is why if you give ChatGPT the same prompt 10 times, it will probably give you 10 completely different responses because temperature defaults to a non-zero value. If you lower temperature to 0, the responses will be a lot more consistent from run to run, but they may not feel as natural as you think they should. So temperature is a knob that we can turn when we make calls to the ChatGPT API. 0 value means we're telling ChatGPT to always pick the next word with the highest probability, but higher temperature values say, hey, inject some randomness into this and pick words with lower probability instead. Before we go into my code, there's something I want you to take away from this. ChatGPT is a word predictor. At the end of the day, that's all it is. It is a very, very sophisticated deep learning model with 175 billion parameters, which were trained at great expense on about 500 billion words. So it knows the structure of several languages really, really well. And it knows, given a sequence of words, what word is most likely to come next. ChatGPT is not sentient. It does not qualify as artificial general intelligence. It's not even close. It is just a next word predictor and nothing more. And that's why you can coerce it into saying inappropriate things or into admitting that it wants to take over the world. It will output that, but it has no idea what it's saying. Now, over time, as they do additional fine-tuning and reinforcement learning, you'll probably see it become less and less likely to generate inappropriate responses like that. But we need not fear for now that ChatGPT is going to take over the world. It's not smart. It is just a huge, very sophisticated statistical model that can look at a pair of inputs and predict what the next word should be. That's all it does at the end of the day. Now, with that, we're going to go look at some code. By the way, that URL you saw on that slide, I failed to point out. Let me just go back to that right here. That's the URL of the public GitHub repo where I parked the examples that I'm about to show you. So let's go over there. So what I'm going to do here, I'm going to run through this fairly quickly here since we've only got about 18 minutes left. But I built a bunch of samples showing how to use the ChatGPT API to do a lot of interesting things. And although you didn't see this, what I've done is I've already obtained an API key. And I created an environment variable named API key in the process in which this Jupyter notebook is running, so that in this very first cell here, when I run the first cell, we're pulling that API key from the environment variable, handing it over to OpenAI, so now it will travel up in every HTTP request that goes to ChatGPT. So let's start simple. We're going to use the ChatGPT API to describe molecular biology in the style of Dr. Seuss. So I'll click run to run the cell, and you see that it's thinking. The call has gone out to ChatGPT. It is generating the response right now, but we don't actually see what it's generating because the way I called it, the call that I made didn't return until all of the text had been generated. We can see here what it generated, but I can modify that code just a bit, as you saw on the slides, to stream the response back. So same command being passed into ChatGPT, but this time as it executes, you actually see the text that's being generated as it's generated. Doesn't change what's being generated, just provides a more pleasant user experience. So something that's very useful to know about if you're going to build applications that use ChatGPT. Now, let me say a little bit more about the commands or the prompts that we're passing into ChatGPT. If you played with any of the earlier OpenAI models like GPT-3, you may recall there was just a simple parameter in which we passed in a prompt like describe molecular biology for me. With ChatGPT, we use a language called ChatML, chat markup language, which is what this messages array translates into. So you may wonder, why did they do this? Why don't I just pass in a simple prompt? And what does role user mean? Well, let me show you here. In this example, I'm starting a conversation with ChatGPT. I'm giving it my name and asking it what its name is. And it's going to tell me, sorry, I don't have a name. But look at this. This messages array is just that. It's an array. You can not only pass in commands from you, the user, you can also pass commands to ChatGPT from the system. You can give it a name. You can tell it how to behave. You can tell it to be friendly or sarcastic. You can tell it if you want, hey, if you don't know the answer to a question, simply say, I don't know. And to a large extent, ChatGPT will obey those commands. So here in my call to ChatGPT, I'm telling ChatGPT what its name is. Then I'm giving it my name and asking it its name. And this time it's going to respond with something like, hey, my name is Sam. What can I do for you today? Now, let me show you this. These messages arrays can grow quite large. Take a look at this example where I give ChatGPT a name, then give it my name and immediately ask it its name. So we should see something like, hey, my name is Sam. It tells us I'm a chatbot designed to help you. How can I assist you today? But now I'm going to immediately make a call that asks ChatGPT for its name. And watch what happens. It doesn't know its name, even though in the previous call, we told it its name is Sam. What's going on here is something simple. Calls to ChatGPT are stateless. ChatGPT does not remember anything you told it in the previous call when you make the next call. However, you can give it a memory by repeating previous parts of the conversation in subsequent calls. Now, take a look at this. I'm going to go to this one. Here, I'm giving in the messages array, I'm passing essentially 4 instructions to ChatGPT. I'm telling it it's a friendly chatbot named Sam, telling it my name, immediately asking it its name, and then asking my name. And watch what the response is this time. Because I repeated the part of the conversation, where I gave it my name, it knows that my name is Jeff. Again, these calls are stateless. ChatGPT does not remember anything you told it or commanded it to do from one call to the next. But if you want to build a conversational chatbot, what you can do is basically just record the conversation as you go back and forth and replay it to ChatGPT by adding it to the messages array. And then ChatGPT has a memory. It can reach back and remember that, hey, 5 lines ago, you told it that your name is Jeff, and it can pull that name up. Now, if you're going to build a chatbot, one of the things you'll need to be concerned about is the growth of that messages array. There's a finite amount of data that you can pass into ChatGPT in a single call, and a finite amount of data that you can get out. For ChatGPT, the default is about 2,048 tokens. That's the combined input and output. The maximum you can set it to through a parameter named max tokens is 4,096. But that begs the question, what is a token? In fact, when you read the ChatGPT documentation and it talks about tokens, what is it really saying? Well, when I showed you a few moments ago how ChatGPT predicts the next word in the output, I was fuzzing things just a bit. It doesn't actually predict words, it predicts tokens. And in fact, when you input text to it, it tokenizes that text before it processes it. So what is tokenization? Well, it turns out that neural networks cannot deal with text, at least not directly. They only deal with numbers. So before we input text to a neural network, we tokenize it. And there are a half a dozen different popular tokenization mechanisms that are used today. A lot of Google models use a tokenization format called word piece, for example, that was introduced with BERT back in 2018. The GPT models, including ChatGPT, use a tokenization algorithm called byte pair encoding, or BPE. And you can see here how it translates 7 years ago, which is 5 words, into tokens. It turns that into 7 tokens. As a rule of thumb, 3 words translate to about 4 tokens. And the good news is you don't have to understand what the tokenization format is or what's happening. But if you are counting tokens because you're making calls to ChatGPT and you need to be able to count the number of tokens in your input, for example, then it's useful to know that tokenization is occurring. And I've shown a little bit of code here that lets you take a piece of text like this right here and compute how many tokens that amounts to. So that is, I believe, it's like 58 or 59 words, I believe. Using this library called TickToken, we can easily compute that translates into 78 BPE tokens. There's also some code here that will take an entire messages array and compute the number of tokens that it comprises. So I threw those in there because if you're going to be using the ChatGPT API, at some point you'll probably find it useful to be able to count tokens in your code to make sure that you don't, for example, pass in more than ChatGPT can expect, or rather can accept. So now let's put ChatGPT to work. One of the many things ChatGPT can do is translate between dozens of different languages. So suppose you produce product manuals for something your company sells, and you want to produce those product manuals in 10 or 20 different languages, which a lot of companies do these days. One option you could use ChatGPT to translate those product manuals. Now, you can't feed an entire manual that may be 100 pages long or 200 pages long into ChatGPT. But what you can do is break it up into smaller pieces, maybe a page at a time, a couple pages at a time, and translate them in sections, then glue everything back together at the end. Here, I'm simply asking ChatGPT to translate the text you saw up here into French. So let's see how it responds to that. Now, I'm not streaming the response, so there'll be a short delay here while the entire response is generated. But in a moment, we should see a pretty good French translation of that English paragraph you saw above. When I use ChatGPT or I play with it, I'm always looking for ways to trip it up. And I wondered, does it know Klingon? Well, it seems that it does. Take a look at this. I'm going to ask it to translate that same paragraph into Klingon, and it works. Now, I don't speak Klingon, so I don't know if that's accurate or not. To be honest with you, I've never been a big Star Trek fan. I know there are people who can speak and write Klingon. Maybe some of them could tell us whether this is an accurate translation or not, but ChatGPT appears to know Klingon. Another way that companies are using ChatGPT is to take marketing text and emails and other collateral and just dress it up. So I'm going to take a rather plain description of this webinar, learn how AI works and how it's used in business, and ask ChatGPT to make that more engaging. Now, if I run this code right here 10 times, I'll get 10 different results unless I set temperature to 0. And you can look at what it produced here. You may not want to use that verbatim, but hey, you could take that and edit it a bit and maybe come up with something that is more engaging than what you had originally, faster than if you had to do it by hand. Another common task in the world of natural language processing is sentiment analysis, looking at a review left on your company's website or a tweet or something, and figuring out whether the sentiment expressed in that text is positive or negative. And there are dozens of different ways to do this in machine learning and deep learning, but guess what? ChatGPT can do it too. Here I'm asking it to tell me whether great food and excellent service is a positive or negative comment. It tells me that feels pretty positive to me. Then I ask it to do the same for long lines and poor customer service. I think that's a pretty negative comment, and ChatGPT does as well. Now, what about this? What about spam filtering? One of the things when I go out and teach classes on machine learning and AI, I teach people how to build spam filters. Today, we can build spam filters using ChatGPT. Here, we're asking it whether this email, please plan to attend the code review at 2 p.m. this afternoon, is spam or not. And it should tell us that it does not appear to be spam. On the other hand, order prescription meds online and save dollars, that sounds like spam to me, and it looks like ChatGPT agrees. Another thing we can do with ChatGPT, and this leads into a demo I'm going to do in a few moments, is use it simply to answer questions. Now, if I want to know, for example, in which deep learning, in which academic paper was the transformer introduced, pretty good chance that ChatGPT knows about it, because remember, it was trained on essentially a snapshot of the internet in September 2021, and this paper was produced back in 2017. So indeed, it knows what that paper was titled and can even give me a URL to it. Now, sometimes it actually gives you a URL. Let's run it again and see if it'll give us an actual URL. That time it just referred us to the website. This time it gave us an actual URL. By the way, something that's really important to know about ChatGPT, in case you don't know it already, when I ask it a question like this, it does not crawl the web to find an answer. When it was trained on a snapshot of the internet, all of that knowledge was baked into those 175 billion parameters. So it could be running in an air-gapped environment where it has no access to the internet, and it would still be capable of answering this question right here. Now, by the way, if you ask it a question about recent events, like something that's happened since the first of this year, it probably won't know the answer because it was trained on a snapshot from 2021. Here's something that I found kind of interesting. Let's take this text up here that describes my hobby, building and flying radio-controlled jets. It describes some of the jets that I've built. Nowhere does it say Jeff has built 4 jets or anything like that. But let's ask ChatGPT to ingest that text and then answer a question from it. So I'm going to ask it, how many jets has Jeff built? And notice what I'm doing in the prompt here. I'm saying, answer the following question using the provided context. In other words, forget about what you learned when you were trained on that snapshot of the internet. Take that question up there or that context and answer this question from that. So here, ChatGPT is going to be a lot less likely to hallucinate because it's not using all of that knowledge that was that it gained when it was trained on the internet. Now, can it actually ingest that and understand what was said in that paragraph enough to count the number of jets that I've built? Well, let's find out. It says Jeff has built 4 jets. That is pretty remarkable. Most question answering systems, including the one that powers Google, cannot look at a paragraph like that and count up the number of jets I've built. ChatGPT can, and I'll show you additional examples as well of the cool things that it can do in terms of question and answering. One of the things I did, because I know of folks who are, for example, taking transcripts of calls with customers and then using ChatGPT to answer questions from those call transcripts that will later go into statements of work or scoping documents. I took the transcript of an interview that Elon Musk did a while back with NPR, and the file is in this repo with musk.txt if you want to look at it. But one of the things that they asked about in the interview was, about his various companies, how those companies came to be, what role he plays with the companies, and things like that. Here, I'm passing that transcript into ChatGPT and saying, forget about what you know from the internet. Just look at this context, this transcript, and answer the following question from it. And oh, by the way, if you don't know the answer, you can't find it in that context, simply say, I don't know. So I'll run that cell. And what we find is, and if you compare this to the text that I fed into it, this is not text that was taken verbatim from that context. It is text that was basically generated by ChatGPT the way a human would ingest the context and then remunerate it in their own words. Now, hope you don't mind. I'm going to go over just a few minutes. I'll try not to go over too many, but I've got more cool stuff to show you here. We all know that ChatGPT can generate prose. It can answer questions from context we provide, or questions from the knowledge that it gained when it was trained on a snapshot of the internet and a large corpus of books and things like that. Lesser known is that it's really good at generating code. In fact, it is a model very similar to this that is the brains behind GitHub Copilot, if you've played with that. So it turns out not only was ChatGPT trained on a snapshot of the internet and a bunch of other stuff, it was also trained on more than 1 billion lines of code from GitHub. Now, there's some controversy surrounding this. In fact, Microsoft, OpenAI, and GitHub are the targets of a lawsuit right now, a class action lawsuit saying, hey, it's not fair and maybe not legal to build a model that spits out code based on the work of others, those billions of lines of code which were written by a human. It's way too early to tell how that lawsuit is going to turn out, but for now at least, we can use ChatGPT to generate code. And if you're a software developer, you may already yourself, or you may know people who are using it quite a lot. Things I used to go to Stack Overflow for example, now I'll just go to ChatGPT, type in a description of the code I want, and 9 times out of 10, it generates the code I want. Just one example, a few weeks ago, I needed some Python code to read a PNG file and generate a NumPy array of 1s and 0s from the transparent pixels in the alpha channel of that PNG. So I thought, it's probably going to take me a few minutes to write that. Could go to Stack Overflow. I went and typed that description into ChatGPT. It spit out 3 perfect lines of code that worked perfectly, so I didn't have to do anything else. So it's a great tool to have. But here are just some examples here. Here we're going to ask ChatGPT to generate a Python function that implements a bubble sort. And I'm streaming the response back so we can see it as it appears. And it's going above and beyond. It's not only going to generate the code, you can see it generates some language describing what the code does, how it works, and things like that. And it's fun. If I ran this cell 10 times, you would see 10 slightly different responses because I'm not setting temperature to 0. And by the way, that's a pretty decent implementation of a bubble sort in Python. Guess what else you can do? You can feed code into it and ask it to describe that code for you. So here I'm taking the same code that it just generated, and I'm going to ask it to describe it for me. Now imagine, you come onto a software project where there are hundreds of source code files and you're not familiar with them because you haven't worked on this project before, and the first thing you do is dive in and try to understand what the code does, how it works, and stuff like that. You could easily build a tool that would help you do that, to help you understand what the code does by generating textual descriptions like this. What about converting from one language to another? Always the holy grail of sorts, like converting VB.NET to C# or vice versa, or converting Java to C# or vice versa. Could ChatGPT take that Python bubble sort function and convert it to Fortran? Well, believe it or not, it knows Fortran pretty well. It knows dozens of programming languages. And thinking back to my Fortran days many, many years ago, I think that's a pretty good version of that same bubble sort in Fortran. What about this? Let's ask it the comments encode for us. So I'm going to take that bubble sort that it generated and ask it to add inline comments. Because of the understanding that it gained when it was trained on more than 1 billion lines of codes from GitHub, it can take that code, it can generate inline comments for you, as you see here. Now imagine this. You could use this capability to build a tool that takes source code files as input and adds comments to them. I've even heard of people building tools like this that will then check the commented source code files into GitHub and generate a pull request so that a human can review what's been added to the files, and if they complete the pull request, we'll merge them right back into the branch. So what I've done here is taken a little file named app.py. Let me show you what it looks like. It is in my data folder. It's a fairly short Python file. I'm opening it here in Visual Studio Code. It's actually the code for a Flask website, code that we're going to be looking at in just a moment. And you can see that the code is completely uncommented. Well, watch this. I'm going to ask ChatGPT to take that source code file, to add inline comments to it. Then I'm going to save the commented source code file out in a file named app-commented.py. So I actually don't have to wait for it to come. Well, I probably do now. I already have that app commented file sitting there, but it's being overwritten right now. So let's wait for ChatGPT to finish doing its work, wait for this asterisk to disappear, and then we'll go take a look at the PY file that it generated. So is it there yet? It's there, but it looks like we're still adding to it. Let's see, out of curiosity, if I opened it right now. There we go, it's finished. So I'm opening that file, and there's the same source code file with comments. By the way, these comments are pretty remarkable. I am using a BERT model from Hugging Face's website to tokenize text and to answer questions from text. It knows I'm using a BERT model. It knows I'm creating a tokenizer. It knows I'm using dot products to quantify the similarity between two embedding vectors. It's pretty darn amazing what it was able to infer by looking at this code and adding all of those comments in there. By the way, it can do it not just with Python, but with dozens of other languages as well. I won't take the time to show it since we're running a little bit over, but here I ask it to do the same thing with a C# source code file. In this source code file, I'm using Microsoft's ML.NET machine learning library. Guess what? ChatGPT knows that library pretty well and added very helpful comments to the source code. It can even do things like this. Here's some old style C# code that uses a bunch of for each loops that could today be written a lot more efficiently using LINQ. So why don't we ask ChatGPT to take that old style C# code and rewrite it using LINQ? Look at that. 2 really beautiful lines of C# to do the same thing using LINQ. What about SQL queries? Can it generate those? I don't know about you, but I don't use SQL every day. I may write a non-trivial SQL query once every 6 months. So when they're non-trivial, it takes me time. Look at this. I'm going to ask it to create a SQL query to do what's described here, and I'll even give it the schema of the table. Now, we'll sit back and watch ChatGPT do its thing. It generates a SQL query. Now, if you do SQL every day, this is probably easy for you. That probably would have been 2 or 3 hours work for me just because I don't think in SQL. There are lots of other things you can do too. Let me just go down to this final example here. Generate a Flask website whose homepage contains a text field in which the user types a comment, including a button that when clicked analyzes the comment for sentiment. In other words, build the website for me, build the web pages, make it a Flask website. Flask is a popular web programming framework for Python. Now, we know that ChatGPT can't create files for us. All it can do is generate text. But look what it does when I ask it to do this. It will actually generate very detailed instructions for the files that will make up this site and what should be in the files, the Python files, the HTML files, and everything else. And you can take these things and you can pour them into the files using copy and paste and try it. And you'll find that, yes, it is a Python website that lets you type a comment. It analyzes that comment for sentiment and shows what the sentiment score is, a value from 0 to 1, indicating how negative or positive that comment is. So I'm going to stop right there with this example because I want to close out with two examples that are a little bit more indicative of the kinds of things that companies are building today. So both of these examples are also in that public GitHub repo. The first one lets me ask questions about the US Constitution, and what it uses under the hood is the same thing that Google uses. When I type in a question, I vectorize the text of that question to generate an embedding vector. I find similar embedding vectors that I generated when I took each paragraph of the Constitution and turned each one into an embedding vector. And then I feed the top 3 or 4 or 5 paragraphs from the Constitution, which the embedding vectors tell me might contain an answer to the question, into an instance of BERT that has been fine-tuned on Stanford's Quad 2.0 data set to answer questions from the text I provide. So I could ask it questions like, can a president be impeached? And if so, how? And because we're using BERT here, a fine-tuned version of BERT that can only find answers to questions from text I give it and answer them verbatim, this is the answer it gives me. It found this paragraph in the Constitution about impeaching a president, and it actually gave me the offsets, the beginning and ending offset of the text removed from office. It believes that that is the answer. That's close, but I think you'll agree that it's not as good as it could be. And it didn't even address the part of the question that said, and if so, how? Now, the code for that, if you want to see how it works, is in that repo. But look what happens when we do the same thing using ChatGPT as a front end. Now, this is a proxy for a very common question that customers are asking us and that we're helping them with almost every day. And that is, how can I use ChatGPT as a natural language interface over my company's proprietary data, stored in SharePoint documents, stored in Azure Blob Storage, stored in any number of places? How can I put a rich ChatGPT interface over it to make information in it more easily discoverable? What I've done here is essentially the same thing, and I'll show you the code in just a second. I've taken each paragraph of the Constitution, used OpenAI APIs to generate very intelligent embedding vectors from each paragraph. When you type a question, like can a president be impeached, and if so, how? I use the same OpenAI API to generate an embedding vector from the question, find the 4 or 5 most similar embedding vectors, feed the text that corresponds to those vectors into ChatGPT, and give it a chance to answer the question. And the cool thing about ChatGPT is it's not limited to just returning verbatim answers. It can actually understand what I'm asking, understand all the context that I passed in from those select paragraphs from the Constitution, and give me a much richer natural language answer than any other model can. You can see the results right here. Again, this is something that we are talking to customers about almost every day. Everyone is wondering, how do we put ChatGPT over custom data? This is a simple example, but this is the basic approach for doing it. Now, let me close just by taking a quick look at the code here so you can see what it took to build that demo that you just saw. And there's actually not that much code here. I'll open in Visual Studio Code, and let's see here, okay? So here's the app.py file. This was a Flask website. that we were looking at in the browser. And this is the code that runs when that app starts up. First thing it does is it pulls my OpenAI API key from the environment. It then deserializes all of the embedding vectors that I generated from the paragraphs in the Constitution and loads them into memory. I'm doing this because I don't want to go re-vectorize all that text every time the website starts up. I want to do that once out of band and then just make the results available to the website. And again, I generated those embedding vectors using an OpenAI API. Now, when the user types a question and clicks the button, my answer query function executes. And you can see here, I first call a local function that searches those in-memory embedding vectors to find the ones most similar to the embedding vector that is generated right here from the question that the user answered. Then I fire off a call to ChatGPT saying, answer the following question from the provided context. And if you don't know the answer, say, I don't know. Then I pass in those paragraphs from the Constitution that I identified via the embedding vectors and the question that the user typed. And when the response comes back, that's the response that I display to the user, the answer to their question. Now, this is a simple example. I'm not using a vector database. They're just 60 or 70 or so paragraphs in the US Constitution. So I'm just storing the embedding vectors in memory. But we could easily take this and build on it by creating, say, a Pinecone or a Malvis database, vector database, so that we could scale this thing out so it works not just with 60 or 70 paragraphs, but with millions or even billions of paragraphs. So you can download the code from that GitHub repo. You can take it further if you want to, but this shows the essential elements in putting ChatGPT over your custom data. So that's not too bad. I only went over by 15 minutes. Assuming you're still with me, you haven't run off screaming, pulling your hair out, I'd be glad to answer a few questions for you. Also remember, and let me pull that URL back up, all the code samples that I just showed you, you can find at this URL right here. It's the URL of a public GitHub repo. And most likely I'll be adding samples to that repo from time to time, so feel free to check back. See if there's something new. Feel free to share it with colleagues, pass it out to your friends and family members when you go out to dinner and stuff like that, because I'm sure that they too will want to hear about all the cool things that you learned today. Rachel, assuming you're still there, have you been monitoring the questions coming in, and are there 2 or 3 that look particularly interesting?
I'm waiting right now, 1 second.
Okay.
Okay, we have a question from Roland. It's, can you talk more about embedding vector?
Yeah, let me say a little bit about embedding vectors. So embedding vectors are incredibly important in deep learning in a lot of different ways. An embedding vector is just an array of floating point numbers that represents a piece of content, typically a piece of text or an image. Some of the cool image generators you may have seen that will generate an image from a text prompt that you type, what they first do is convert the text into a text embedding. Then they run that through a model that generates an image embedding from that text, and then they run that through the image embedding through another model that actually turns that image embedding back to pixels. So an embedding is just a floating point representation of a piece of content and the meaning of that content, or the contents of what's inside it if it's an image. And it turns out that OpenAI, one of the other models that they expose, is one that generates very, very smart embedding vectors. I used that OpenAI API, it's called the Embeddings API, to generate the embeddings for the paragraphs in the US Constitution. I also used it to generate an embedding for the question that the user asked. And just to make it clear, the magic of the embedding vector is that it actually encapsulates the meaning and the context of the text. What that means is, if I generate embedding vectors for 2 different sentences, but sentences that may kind of have to do with the same thing, if I measure the similarity of those two embedding vectors by simply taking their dot product. The more similar those sentences are, the closer the dot product will be to 1. On the other hand, if I generate embedding vectors for two sentences that have absolutely nothing whatsoever to do with each other, and then take the dot product of the two embedding vectors, that dot product will be something very close to 0, indicating these two sentences don't appear to be related. Good question there. Rachel, any others you see that might be interesting to kick around some?
I'm scrolling through 1 second. Okay.
By the way, Rachel is our resident marketing genius. I think that you'll receive a follow-up survey from her sometime soon, along with a link to the recording of this. Yeah, very good. So what you got there, Rachel?
Okay. We've seen that you can use ChatGPT to create shorter code snippets, a little bit out of context. How about more complex software parts? Can it create multiple classes taken into consideration, solid principles, for example?
It actually can, believe it or not. The chief limitation, and by the way, for any given thing that you wonder if it can do code-wise, the only way to know for sure is to do it. I will say that for me, I've been astonished at the things that it can do. That's not to say it can do everything. The chief limitation you'll run into is that, remember with ChatGPT, the most tokens that it can process, combined input and output, is 4,096, which probably translates to about 3,000 words of code. So it's not going to be able to generate for you a source code file with 10,000 lines. You're going to have to chunk that up somehow. Now, one thing that can help alleviate that somewhat is if you use Microsoft Azure, you can get access to GPT-4. You can also access GPT-4 through OpenAI if you buy a paid ChatGPT Plus description. And guess what? There are two versions of GPT-4. One raises the token limit to 8,000 tokens per call. The other raises the token limit to 32,000 tokens per call. So by using GPT-4 there rather than ChatGPT, you could have it generate a much longer source code file. Yes, complete with classes, with knowledge of solid principles and things like that. It'll be interesting to see what happens in the future. My guess is over time, those max token limits will be raised more and more. So we'll see these models being able to generate much lengthier and more complex code. But there's no doubt that today, that because of those max token limits, we do have to do some work on our end to fit within those limits. Rachel, how about one more?
Okay, let me look. There's a few coming in now.
Well, maybe we'll take a few. You know what? And I apologize for running over, folks. If you need to leave, you have a meeting or lunch or something, feel free to drop off. You're not going to hurt my feelings one bit. For the rest of you, if you want to stay maybe another 5 minutes and get a few more questions answered, I'd be happy to do that.
All right, I have a question from Stephen. How does the deep learning model store the tokens?
Okay, good question. How does the deep learning model store the tokens? So if you're thinking, it doesn't persist the tokens, it converts the text that you input into tokens. Then those tokens essentially just become an array of floating point numbers, and that array is then input to the deep learning model. They don't persist those tokens per se. And when I say per se, I should explain just a little bit. There are some concerns around, hey, when I submit a request to ChatGPT, is OpenAI or is Microsoft storing that? And you can look at their at the documentation they've produced on the rules. I believe Microsoft now says they don't store this at all. They immediately forget it. OpenAI for a while, I think by using the API, you were giving them the right to retain the data for 30 days or something so that they could use it to train additional models. I think maybe they've even backed off on that now and are saying that they're not going to use the data either. But the tokens themselves are not persisted. Anything else, Rachel?
Let me see. Okay, this one from Roland, or did I do this one? If I had rows in a database with a description and price, could you store those vectors in load? It says 10, 00, 000 rows to do the estimates.
Yeah, so it sounds like we're talking about a vector database where essentially the keys in a table are embedding vectors, and the values in the fields in the remainder of the table are whatever corresponds to those vectors, paragraphs of text, for example. So could could that database have 100 million rows and you pull out just the ones that you need to feed into ChatGPT? Yes, remember, you can only feed a limited amount of text into ChatGPT in one call. So that's the whole intent of the vector database. You may have millions or billions of rows in there, each characterized by a unique embedding vector. But then you can query a vector database. In the query, you say, give me the n embedding vectors that are the most similar to this one, and internally it uses dot products or cosine similarity or some other measure to find the n embedding vectors and the corresponding content that most closely match it. That's how we build highly scalable systems. We're not trying to send all million rows into ChatGPT. We're using embeddings and similarity measures to find the ones that are most likely to contain what we want and feeding just those into ChatGPT. And just to be clear, because I've had some discussions around this with customers, we never feed an embedding vector itself into ChatGPT. It has no idea what to do with an embedding vector. We use embedding vectors to find the text that we want to feed into it. And ChatGPT then is happy to accept that text and use it as a context for answering questions or whatever it is that you want it to do with it. So Rachel, why don't we take one more and then we will bring things to a formal close.
Right, and I can just send you the other questions and you could reach out after this.
Yeah, and if there are questions you really need to get answered, feel free to contact me or contact Rachel. One of the things that we do and that I do in particular at Atmosera is we work with customers, understand their business, the challenges they're facing. We help them identify ways in which they can use AI to make their business more efficient. So we're always happy to engage in a conversation, and if we can help you get a leg up and make amazing things happen with AI, we are always happy to have that conversation.
Okay, so last question. When we use the ChatGPT web interface and build a conversation to generate content or other data, what mechanism is used to preserve the context?
To preserve the context. So, and just to make sure I understand, let's say that you go to the ChatGPT website and you're typing in commands there, and then it is generating responses. So, what mechanism is being used to persist the responses? So, I do know that ChatGPT stores those responses, or OpenAI stores them, because when I go back to the ChatGPT website, I can actually see a list of the questions or the prompts I've input and the responses that have been given. They're probably storing those in a database somewhere. I'm not sure. I don't know how long they store them. That information may be available somewhere on the OpenAI website, but I honestly don't know, when you're just using the website, where they're storing those responses or how long they're keeping them. So I'm going to go ahead and draw to a close here because I've gone over almost a half hour. Let me thank you again for giving us an hour and a half of your time. Hope it's been interesting. I hope it's been enlightening. I hope you came away with ideas of things that you can do to use ChatGPT to make your business better or to make your app smarter. And if there's nothing else that you take away from this webinar, let me remind you of this. ChatGPT is not sentient. It is not AGI, artificial general intelligence. There is no risk, at least as of yet, that it's going to take over the world. It is just a very, very clever piece of code that was trained up on lots of data, and from that training has learned to take a pair of inputs and predict what the next word and the second input should be. And by calling itself iteratively, it can generate responses that feel very human-like. It's nothing more than a word predictor, but there are lots and lots of ways that we can leverage that in our business, one of which is using ChatGPT as a natural language interface over the documents, the HR documents, other documents we have at our company, to make the content in them more easily discoverable. So with that, I'll sign off. Again, thank you for your time. Feel free to reach out to us if we can help you in any way, if we can answer additional questions, if you want to do a brainstorming session between us and some of the folks at your company, just to talk about some of the things you're doing and see if we can come up with ways that AI might help it. Feel free to reach out. We're always happy to have those conversations. Thank you so much and have a great rest of the day.